Okay, dear students, welcome to the fifth lecture of ICGT. Just let me settle. I'll talk about engine performance and lubrication. The viscosity of lubricating oil has a considerable effect on engine performance. The viscosity of lubricating oil has a considerable effect on engine performance. Means the viscosity of the lubricating oil has got an effect on engine performance. I told and again, too high viscosity means loss of power. Reduced torque, reduced power output. I told in the last class, too high viscosity means the lubricating losses its fluid character. The moment it loses fluid character, it doesn't get circulated properly within the engine piston cylinder arrangement. When it doesn't get circulated properly in the piston cylinder arrangement, as a result of that, there is more friction. When the friction happens, a lot of power goes into running the piston within the cylinder. Since a lot of power goes into running the piston within the cylinder, the output power of the wheel at the wheel decreases. So we get a loss of power due to too high friction when the viscosity of the engine is too high. When the viscosity of the engine is too low, this is the second case. Two extremes we are talking. When too high, this is the disadvantage. The second case, when the viscosity of engine is too low. Too low viscosity of the engine means poor sealing. Poor sealing means increased blow by increased oxidation. There is increased fuel consumption. Too low means poor sealing, number one, because too low viscosity means the viscous character of the engine has gone, oil has gone. When the viscous character of the oil is gone, the lubricating fuel loses its original property and has a tendency to get oxidized. When it gets oxidized, it forms rust-like materials within the piston cylinder arrangement, and friction increases, and this increases the oil consumption. So what we learned here, too high viscosity is bad as well as too low viscosity is bad. Viscosity should be well balanced between too high and too low. Increased temperature would reduce viscosity of the lubricating oil. Hence, selection of oil with SI grading plays an important role in engine performance. The last class I was talking a lot about selection of SI grade oils. I showed you the SI grade oils which are working in winter at particular viscosity and working at summer at particular viscosity. At winter it is working at a low viscosity, the same oil at summer is working at higher viscosity. The tendency is opposite. In case of winter, the low viscosity oil works better. A high viscosity oil in winter coagulates, forms a solid structure and doesn't get circulated. So a low viscosity oil works better in wintry condition. In case of summer, the temperature is high, the fluid loses its fluidity. So it should be having a high viscous oil. That is why in the last class I was talking of SI grade oil with particular grade in winter and the same oil having a particular grade in summer, if you remember. Now we'll be talking about necessity of engine cooling, disadvantage of overcooling and all these things. Engine cooling we'll be talking. The moment we come to the engine cooling, Remember one important point. Coolant plays a very important role in an engine. The engine runs at a high speed, runs for a number of hours in the highway if you are going to a long distance, and it gets heated very easily because there is a continuous friction of piston cylinder within the arrangement. There is a high speed of the engine due to which the piston cylinder goes up and down very fast, and because of all these factors the temperature of the engine increases tremendously. So it is necessity to decrease the temperature of the engine using coolant. Now it cannot be that you are using the coolant, decreasing the temperature of the engine, and then coolant is going out. Cannot be. It cannot be an open circuit. It should be a closed circuit. The same coolant will be used again and again because the coolant is very costly in an engine. If you are driving a car, you know the cost of the coolant. You must have bought coolant. So in case of engine, the coolant temperature increases tremendously. And the coolant should be able to withstand the temperature. So it cools the engine accordingly. It absorbs heat from the engine. Coolant absorbs heat from the engine and the engine becomes cold. Now, after the coolant absorbs heat from the engine, the coolant itself becomes hot. So that coolant is to be cooled. That cooling is done in a radiator. You have heard the name of the radiator in an engine? It is a very popular term, radiator of an engine. If you have some idea of a car, you have idea of radiator. The radiator, the name itself indicates, it radiates heat. That means, whenever the coolant cools the engine, itself becomes hot. That hot coolant comes into the radiator, gets cooled in the radiator and goes to the engine again, being cooled. The cycle is a closed cycle. You are understanding that, na? I hope you are understanding what I am telling. Again, try to understand. The coolant absorbs heat from the engine. So, engine which is at high temperature becomes cold. Now, the coolant has become hot because it absorbed the heat in the engine. The engine, remember, the energy cannot be destroyed. The energy can be transferred from one form to another. So, we have transferred the engine, heat of the engine from the engine to the coolant. Coolant is hot now. Now, this coolant is to be cooled. It is brought to the radiator. In the radiator, it is cooled. And then cold coolant is again recirculated to the engine. Using those characteristics, here you can see, we are using these characteristics here. You can see this particular diagram. In this case, we are showing this is a fan. This is radiator. There is a fan, there is a radiator, there is piston cylinder arrangement. This red part comes to the upper part of the engine. You can see the upper part of the fan, the upper portion of the fan, the red part of the fluid or coolant. That is the hot. Red part, reddish means hot. It comes within the radiator. This is the radiator in which it is coming. Near radiator, the fan rotates and the coolant becomes cooled in the radiator. This cold liquid gets collected at the bottom. Always remember, whenever something gets cooled, its tendency is to increase its density. Something becomes cold means increases density and it comes down. For example, in your house you have a domestic refrigerator, freeze. In the freeze, generally the deep freezer remains on the top of the freezer. Deep freezer is the portion where the cooling takes place. And from that deep freezer, the cold air goes down to the vegetable basket and cools it, which is at the bottom of the vegetable basket, and cools it. Because of the cold air, it has a high density and has a tendency to go down. Taking the same principle here, as the hot coolant from the piston cylinder arrangement goes into the radiator, it gets cooled in the radiator, turns from reddish to bluish. You can see as it gets cold, it turns from reddish to bluish, and the bluish part gets collected in the bottom of the radiator. Bluish part getting collected at the bottom of the radiator. Here is the bottom. From the bottom, it again comes back to the engine, goes to different parts of the cylinder, cools it, again gets hot, becomes red in color, goes up to the radiator, at the higher level to the radiator, and comes down, and from the lower level it goes to the engine. That means hot coolant comes to the radiator from the top housing, top hose, you say top hose, HOSE hose, top hose, and goes out of the radiator through the lower hose. This is a natural cycle we are using. By natural cycle, what happens? Again I am telling, the hot one when gets converted to cold one, the density increases and it settles down at the bottom. So from the bottom we take the cold part and supply to the engine. This is how the radiator is working in this case. This is an example of radiator use. You can see here this diagram very minutely. You can see piston cylinder arrangement. In the left of the piston cylinder arrangement there is a fan, and at the extreme left there is a radiator. And the whole arrangement I have explained just now. Now we show you radiator here. You see the radiator here. This is the radiator. This is the radiator. If I show you the radiator, this is the radiator part. In the radiator, there is an expansion tank. Here is the expansion tank. There is a upper hose through which the fluid comes in. There is a lower hose through which the fluid goes out. Fluid means coolant. Remember, in the radiator, hot coolant is coming from the engine. That's coming to the upper hose, coming here. At the upper hose, it's coming. There is an expansion tank. Expansion tank means just a small reservoir kept beside the inlet of the radiator. So what happens? When the temperature is too high, the coolant expands. Anything you know, as per heat transfer, anything gets heated, its volume increases. Similarly, in case of oil, when the temperature increases, the volume increases, and the higher volume goes to the expansion tank part. Do you understanding? It is going to expansion tank part. Means the extra fluid which comes out as a result of volume increase is to be accommodated somewhere. And for accommodating it, we are putting an extra reservoir, that is expansion tank. Then the fluid comes inside the radiator. In the next diagrams, you will see the details of the radiator very clearly. In the radiator, the fan is there. The fan is continuously pumping air through the radiator. So cold air being pumped through the radiator, hot coolant comes in contact with it, not direct contact, through the metal, as it works as a heat exchanger. So it comes in contact with the heat exchanger. As it comes with the heat exchanger, as a result there is a heat transfer from cold air to hot coolant. So hot coolant becomes colder, air becomes hotter. So what happens? If you stand in front of the radiator, you will get a hot air. You will get a hot air because heat is picked up by the air and that is coming out. This is how the radiator is working here. This radiator has got different parts in that. One is upper hose, through the upper hose, the fluid comes inside. Through the lower hose, the fluid goes outside. There are different parts of the radiator diagram shown here. You can see different parts of the radiator diagram shown here. These are the different parts of the radiator, this diagram. And below is shown the exhaust system. Here the exhaust system is indicated to show the nozzle effect. Means if the exhaust system passes through a constricted nozzle means a smaller area, it passes through a smaller area, it gives a opposite thrust to the engine. That is why the engine exhaust outlet is so small as compared to the inlet, you see. We have decreased the area suddenly. So as a result of that, there is a huge thrust on the back side of the engine and the engine is going forward. Exhaust is designed in that way. This is how the exhaust works in case of a radiator. You can see this diagram and everything becomes clear here. I have shown you the radiator part. Now types of cooling system, air cooling, water cooling, radiator. We will be talking something about that. Now this is air cooled system, an engine. Air cooled system engine is generally provided with fins. You have the idea of fins? Fins are the extended surface area structure given to any heat exchanger to provide a better heat transfer. You can see the outside area of these fins. You have seen these areas. You can see the outside extended areas. The small blade-like structures throughout the whole periphery of the engine. These extended areas are throughout the whole engine. You have seen these extended areas in case of motors also. Motors in your house has such extended areas. Motors means pumps. Pumps we generally refer as motors in our house. So in case of motors, you have extended areas. Through the extended areas, a lot of heat is dissipated. Through the extended areas, a lot of heat is dissipated. So that is what the functioning of the fin in case of an air-cooled engine. In case of small engines, this can be used. You don't need a coolant in this case. You are making the engine to lose heat through the fins. For example, your motor in the house rotates continuously, gets extremely heated. But do we use water or coolant to cool that? We don't use. We use air to cool them with an extended fin structure on the outside surface. So those are the air-cooled systems. Heat is transferred from the engine through these fins into the atmosphere. Generally, the heat equation forms the formula Q is equal to U A delta T. If you remember, this is the formula generally used in case of heat transfer. U A delta T. That means Q is equal to, this is Q. Q is equal to, U is overall heat transfer coefficient into A is surface area into delta T is temperature difference. So we are producing Q equal to U A delta T. Now what we are doing, if Q is directly proportional to A, that is the heat transfer is directly proportional to the surface area. As we increase the surface area, the heat transfer increases. And as the heat transfer increases, the engine becomes cooler. So in case of smaller engines, we don't need coolant, outside coolant. In case of smaller engines, we don't need outside water or any other coolant like that. We just use fins through which it is cooled, like motor in your house. And you must have seen in small engines, in many small engine structures, such fins are there through which the heat gets dissipated. Such fins are there. This is a very good way of cooling the engine with a lesser cost. Why lesser cost? Number one, no coolant is required. Number two, no fan is required. Number three, the power lost is more, because if you have to run the fan, you need power for running the fan. If you have to run the coolant, you need a pump to run the coolant. And everything takes power from your bhp, the horsepower of the engine. And the horsepower of the engine at the wheel decreases as a result of that. So if you use air-cooled fin, it is very good. You don't need water, you don't need coolant, or you don't need anything like that. You can see in case of two-stroke engine like scooters, etc., you can see fin structure is there. Because it is a small engine. Here the air cooling is possible. But in case of simple air cooling is natural air cooling without fan or anything. But in case of big engines, you need an external fan like you have in your cars. There is radiator fan. But you remember, whenever you are using a radiator fan, a lot of power goes into pumping the coolant, a lot of power goes into running the fan. That is one aspect of that. Then we are coming to the liquid cooled. That is the coolant, where the coolant is cooled. That we are talking about air cooled, we are talking about a liquid cooled. The liquid coolant is circulated along the cylinders and absorbs heat from the cylinder walls and cylinder head. It absorbs heat from the cylinder walls as well as the cylinder head, the liquid cooled engine. And coolant is a mixture of antifreeze, ethylene glycol, and water. Mixture of antifreeze, ethylene glycol, and water. That is coolant. Both are mixed together. Ethylene glycol adds more to the cooling property of the water. And it is generally used as antifreeze. Now, coolant absorbs heat as it passes through the engine and also lubricates the water pump. As it passes through the water pump, it doesn't get pumped only in the water pump, it lubricates the pump also. Because water pump needs lubrication. And lubricating well which you are using for this purpose doesn't come to water pump for lubricating. It generally lubricates the piston cylinder engine, but doesn't lubricate the water pump. So water pump gets lubricated by the coolant itself. Hot coolant enters the radiator in which the heat is passed onto air that is flowing through the radiator. You can see here in this diagram, this is radiator. Through the radiator, air is continuously passed, and whenever the coolant comes in the radiator, it gets cooled through the air. It is just working as a heat exchanger. Radiator is a good heat exchanger, nothing else. Prevents rust and corrosion from water jackets. Coolant not only does cool the engine, it also prevents rusting because there is a continuous flow of liquid. So if there is any rust formation, any small structure formation, it is washed away by the coolant, and it prevents corrosion from the water jackets. It's a metal structure. It may corrode after a few days, but continuous flow of fluid through the metal jackets reduces the corrosion effect. These are many good sides we are talking about of the engine. Cooling system flush is recommended every 2 years in order to remove any rust or contaminants. Cooling system, what the system flush means, the coolant is to be replaced every 2 years or maybe even less, because there is, as a result of continuous circulation of the coolant through the cycle, there are dirt formation, there is rust formation, there are corrosive matters which are being washed away by it continuously. So after months or maybe 1 or 2 years of operation, lot of rust particles and such things formed in the coolant. That affects the working or cooling capacity of the coolant. The coolant is to be flushed out after every definite period. Every engine manufacturer has a period. They will tell you the coolant is to be replaced after that many period. That's why the servicing is there. No? You have a 6-month servicing, you have 1 year servicing. You have they replace the coolant that time. That is the period during which the coolant gets rusted. We Indians have a tendency to think the servicing is a way to extort money. after the warranty period is over. That's the wrong way of thinking. It's not for that. A regular servicing is required to increase the life of the engine, to increase the performance of the engine in a better way, so the engine works nicely. These are the different parameters. Now you can see water jackets. These are water jackets I am showing you. This diagram shows water jackets. This diagram shows water jackets. This diagram. You can see water jackets. And there are small holes within the cylinder structure. These are water jackets. Designed to keep engine block and cylinder head cool. See, it goes to the interior of the cylinder. The holes are drilled within the cylinder walls. It goes up to the interior of the cylinder through which the coolant moves. So automatically, these cylinder walls get cooled, and the engine temperature, when it increases through the cylinder wall, the heat of the engine goes to the coolant. Coolant gets it cooled. This is the way the engine works. When the engine is running at normal operating temperature, the coolant is forced to the water jackets in the engine block. When the engine is running at normal operating temperature, which is normal temperature in general, what happens? The coolant is forced to the water jackets in the engine block. Coolant is forced due to a pump through the head gasket into the head and the back to the radiator. Through the head gasket and back to the radiator. Now gasket. There is the second term, this is gasket. What is gasket? Gasket is generally used in case of pumps or any rotating structure in the casing to prevent leakage. See, in case of a pump, when you outer casing, you nut and bolt it and put a screw in that, even then the water is passing through that, and there is a chance to leak. Nut bolt tightening is not so foolproof. The liquid doesn't come through it. Liquid comes through it. So a rubber gasket is generally placed in between two nut bolted parts so that the liquid doesn't come out of that. That is to prevent the liquid from coming out. This is the cylinder head gasket which is being used. And as a result of that, there is no leakage or no damage to the cylinder head. This is how the system works. So in case of the cylinder head, we need to provide with the gasket with the proper arrangement. The cooling, I have shown you how the cooling works, how through the cylinder jacket, the pipe, the coolant runs, and you can have a look towards that. This is my 5th lecture. And with this 5th lecture, I thank you for attending the class. Provide your attendance in the Microsoft Teams. Attendance is very important. Don't miss it in any way. And we will meet you in the next class, that is 3rd class, next time. Thank you.